Okay, let's begin. So guys, this is really quite simple. Today what we're doing is 2 dash y, we're going to be, there's a million of you, one of me, so don't talk. So we're going to be solving rational equations today. Now literally, here are the instructions and then we'll just practice. This is all we're learning today. So the nice thing is before we've been dealing with rational expressions. An expression doesn't have an equal sign. So we were simplifying rational expressions, we were adding and subtracting, multiplying and dividing rational expressions. Today, we're going to be solving rational equations. So what makes that an equation is there'll be an equal sign and we're solving. Here are the step-by-step instructions on how to solve. First, to solve an equation containing rational expressions, we get a common denominator. Now, if we get a least common denominator, the equation we have to solve is much smaller and easier. So we'll want to get a least common denominator. Then once you have a least common denominator, you can just solve the variable that makes the numerator true. So it's so nice. Once we get a common denominator, since all of the denominators are the same, when we solve, we just have to solve the numerator. Because of course, if the bottom's the same, it's always going to be the same, right? Even if we solve the top. Does that make sense, everybody? Okay. Now, here's one thing to note. Anytime we're taking and we're multiplying and getting a least common denominator, and we're multiplying both sides of an equation by something different, manipulating equations, we can get extraneous solutions. So an extraneous solution is a solution that is derived from the new equation you just created. So we'll manipulate these correctly, but we might get an equation that gives us a solution that's a solution of the new equation, but it's really not a solution of the original equation we're solving. So the only way to know if this solution is extraneous is by simply checking your answer. So let's say we get answer 2. All you have to do is go back up to the very original problem, plug it in, and if it's a true statement, it's truly a solution. Does that make sense? Let's say we plug in 2 and we get 0 equals 2. That's not a true statement, so that was an extraneous solution. You didn't do it wrong. It's just that solution needs to be thrown out. It's the solution of the new equation, not the old one. Does that make sense? Check your answers. That's how you know if it's extraneous or not. Check your answers. Does anybody need some time to take a picture of this before we just start doing examples? That's the lesson right there. Now we just practice. Okay, number 1. Solve the equation. So what it means is solve for x that will make this a true statement. So we're going to solve by getting a common denominator. So first of all, 10 is really 10 divided by 1. Don't talk. 10 divided by 1. Now we need a least common denominator. Now everybody look. We have a 3, we have a 2. 3 times 2, we have a 1. Isn't my least common denominator 6? Make every denominator 6 then. Here we go. How are we going to make 3 a 6? Multiply by 2. How do we make 2 a 6? Multiply by 3. How do we make 1 a 6? Yep, multiply by 6. So let's rewrite what we have. We have 2x over 6 plus 3x over 6 equals 60 over 6. Now don't be that person that then says, oh, well look, 2 and 6 divide out to be 1/3, and then end up right back at the original problem. Okay? All right. I know. Okay, so let me explain. Now think about it. Our denominators are the exact same. They are the same. So now when we solve for the top, this will be a true statement, and the bottom will stay the same. So we would literally now say, because we have a common denominator, all we have to do is solve using the numerator. 2x plus 3x equals 60. Now look, what type of equation is this? It's a linear equation. Linear equations are easy to solve. So we really have 5x equals 60, solve for x. So x equals 12. Now once again, I want you to notice something. When we got a common denominator, we had a linear equation, so we should only have one solution. What if we would have got a quadratic? How many solutions should we have? 2. All right, now we will check to make sure that's not an extraneous solution. So you'll just make yourself a little spot. And for some reason, but it is the hardest part is just checking your answers. Finding the answers is easy. On the test, what people miss is checking the answers. Here we go. Plug it back into the original. So look, 12 over 3 plus 12 over 2, does that truly equal 10? You see, I plugged it into the original. Now you could use your calculator, but this one we can just do by thinking about it because it's easy. So this is 4 plus 6. equals 10. Does 10 equal 10?
Yeah.
True statement. So x equals 12 was not extraneous because it's true, that worked. That made it a true statement. Pretty easy, right? Let's do another one. Number 2. Here we go. Least common denominator. Now 0 is 0 over 1. Let's find our least common denominator. We have an x, we have a 9. That's 9x times 1. So our least common denominator is 9x. Let's fix our denominator. So what am I going to multiply by here? 9 over 9, right? X over x. And then 9x over 9x. So I have 9 over 9x minus x squared over 9x. That equals 0 times 9x is 0. 0 over 9x. Now look, your denominator is truly the same. So we can literally solve using just our numerator. Because if we get x equals 10, for example, of course our denominators are going to be the same. So we're just solving using the numerator. So 9 minus x squared equals 0. Now look, we have a quadratic. So how many solutions should we have when we do solve? 2. Okay, let's solve the quadratic by factoring, quadratic formula, or the most appropriate method. Easiest way possible. What's the easiest way here? Add x squared, square root it. People, okay, so we're just solving for x. Add x squared. So we have 9 equals x squared. What's my next step? Square root. So x is equal to positive 3 and negative 3 are both solutions as far as we know. Let's go check it. So I make myself a little box where I check. This is where I'm going to check it. I'm going to check x equals 3. I'm also going to check x equals negative 3. Here we go, plug it in. 1 over 3 minus 3 over 9, does that equal 0? Then when I plug it in down here, 1 over negative 3 minus negative 3 over 9, does that equal 0? Now we could just type it into our calculator, but this one is, once again, easy to just look at. Isn't this 1/3? 1/3 minus a third, isn't that 0 equals 0? So x equals 3 is truly a solution. It's not extraneous. Now look right here. Negative a third minus negative 3/9. Isn't that plus 3/9? Which is 1/3. So negative a third plus 1/3. 0 equals 0 is also a true statement. So negative 3 is not extraneous. Not hard, right? Okay, let's do one more maybe. One more, and I'm going to let you go for it for a second. Here we go. Least common denominator. Now, a lot of you get thrown off with, okay, well, what about, we have an x plus 1 here. Well, okay, x plus 1 is connected. There's no other thing, like that's a factor. That's an exact factor. So to get a denominator the same, it has to have an x plus 1. Now, look right here. This is 3x plus 1. It doesn't factor out, and then there's the secret x plus 1 in there. There's no x plus 1 there. Does everybody see? So the least common denominator is literally x plus 1 times 3x plus 1. All right, so this one needs a 3x plus 1. 3x plus 1. I better use parentheses if there's two terms. This one needs an x plus 1. This one needs an x plus 1. Now look at your denominators. Are they truly the same? So we can solve using the numerator. So now we would do negative 4 times 3x. Negative 12x, negative 4 times positive 1. And then 5 equals 5 times x. 5 times positive 1. Well, look at that. We have a linear equation. So let's solve for x. Well, let's combine our x's using algebra. Add 12x. Negative 4 equals 17x plus 5. Does everybody see how I'm just combining like terms here? Subtract 5. Negative 9 equals 17x. So don't we get x equals negative 9 over 17?
Yeah.
Sweet. Let's check it though. This one's a little bit harder to check. Okay, here we go. So we have negative 4. You've got to use parentheses. Honestly, the most missing on the test is people cannot check it correctly. So they'll plug something in wrong and call something extraneous when it's not. Or they won't check and they'll be an extraneous solution. Does that make sense? Okay, here we go. So we have negative 4 divided by parentheses. Now I'm going to use another parentheses since I'm plugging something in. Negative 9 over 17 plus 1. Does that equal 5 over parentheses 3 times negative 9 over 17? Notice how I'm putting my parentheses in, and then plus 1 parentheses. Now all you have to do is calculate this side. Does this decimal equal, type in this side, does that decimal equal that decimal? So ready, go. Pick one. I promise you, if you're one of those people that don't practice checking, you will get it wrong on the test. Yes? Because I promise you that even one of my students that always gets like 100% on every test today, she's like, I keep checking these and I keep getting it wrong. So I was able to help her see, well, you're typing it in wrong, my dear. And oh, you actually rounded the decimal. You can't round the decimal when checking. You can't work out those kinks unless you tried it. And what's the decimal? So negative 8.5, just easy. Just let negative 8.5 on that side. On this side, did you get negative 8.5? Which your fraction's fine. Yeah, as long as it's the same. Perfect. We haven't had any extraneous ones yet. We will in the future, I promise. Okay. Well, ready, go. Let's get as much homework done in class as possible. I want you to do 4 through 9. Okay, go to 11. Not that we're learning anything new. Let's just do some more examples that are a little bit more advanced. Okay, our first step is to get a least common denominator. Now look, guys, if you don't factor out your denominators, you're not going to catch that this already has some stuff in common with this. So you've got to factor out your denominators completely. So rewrite your denominators in factored form. 2 over x plus 3, that doesn't factor. Plus 5, well, what is this factor to be? Well, to know, we've got to rewrite it in standard form. Isn't that piece negative x plus 3? So factored would be plus 5 over, shouldn't we factor out a negative 1? Right. Now right here we have equals 6, and on bottom, this factors to be x plus 3, x minus 3. Now look, if you wouldn't have factored, you wouldn't have seen that there's a lot of stuff already in common. Does that make sense? Now look, this negative 1, we're going to need to get a common denominator with negative 1 or take care of the negative 1. Well, let's just take care of the negative 1. What's 5 divided by negative 1? So I'm going to go ahead and go like this. Boom. Same thing, right? Okay, now we don't have to take care of a negative. Okay, what's my common denominator? X minus 3 and x plus 3, right? So this multiplies by x minus 3, x minus 3. This multiplies by x plus 3, and x plus 3. Now check your denominators. X plus 3, x minus 3, x plus 3, x minus 3, x plus 3, x minus 3. And now we can solve using the top, the numerator. Here we go. 2 times x is 2x. 2 times negative 3, negative 6. Everybody with me? And then we have negative 5 times x, negative 5x. Negative 5 times positive 3, negative 15, and that equals 6. Now look, it's just a linear equation, so combine like terms. So that's negative 3x minus 21x minus 21, no x on that. Hold the x, add 21. So x equals negative 9, and then I would check my answer. So I would be doing, in my checking, I would be doing 2 over negative 9 plus 3 plus 5 over 3 minus negative 9. Does that truly equal 6 over negative 9 squared minus 9? So guys, everybody type this in this side, what do you get? Type in this side, what do you get? So if you type in this side, you get 6 over 72. When you type in this side, do you get 6 over 72? I don't know, you tell me. Yes, you do. So we're good. Once again, I can't tell you how to check your answer besides saying type it in right using parentheses. I can't really teach you much besides you practicing it and saying, oh, I'm not getting the right thing, or I am, because I don't know. You know what I mean? Yeah. Okay, great question. So let's say it was extraneous. It wasn't the same. Then this was our only solution, but it's not a solution. So this one would have, if that was the case, no solution. question. They said, let's say -9, when we plugged it back in, did not work. Since that was our only solution and we checked it, still not us. Since that was our only solution and we checked it and it didn't work, that means there's no solutions. But it did work. So x equals -9 was a solution. They just said, what if it wasn't when we checked it? Okay, questions? Do you want one more where you're going to have to get a least common denominator, or are you good? Do you want me to do 10, or are you good? Okay. Then everybody look at 10 with me. Now, once again, those of you that messed up really bad on the test was because you did not get a least common denominator. You just said, I'm going to just multiply by everything. Well, guess what? This has stuff in common. You're just not seeing it because your denominators aren't factored. So rewrite it with me. What should I factor that to be? 2 and x plus 1, right? And then we have plus 5 over, what is that factor to be? X plus 1, x minus 1. Oh, well, look at that. They're already a stuff in common. And then we have equals 1 over x minus 1. So my least common denominator is 2. X plus 1, right? And x minus 1. Does everybody understand why? If not, you got to ask why. Okay, then let's make all of them look like that. So it looks like this one needs an x minus 1, an x minus 1. This one needs a 2, doesn't it? A 2 and a 2. And this one needs a 2. 2 and an x plus 1, you're right. Now look at your denominators, make absolute sure. Look, 2x plus 1, x minus 1, 2x plus 1, x minus 1, 2x plus 1, x minus 1. So now I can solve these in the top. 1 times x, 1 times -1, so x minus 1. Now this is 10 plus 10. That equals, now people say, well, what order? It doesn't really matter. I'm going to do the easiest order. 1 times 2 is 2. Then 2 times x is 2x. 2 times positive 1 plus 2. And look at that. It's just a linear equation that I need to solve. So I'm going to combine my x's using algebra. I'm going to add these up. That's gone. This is 9. 9 equals x plus 2. X plus 2. Subtract 2. X equals 7. And once again, I would check it to see that it's truly not extraneous. It does work. Okay. So I'm not going to do any more examples. I think, well, Okay, this is my last one. And then I'm going to let you go for it till lunch and then after lunch for a while. So look at this one. This one, we need to find a least common denominator. To know the least common, this is not on your worksheet, by the way. I'm just showing you one real quick. If you need to take notes, you can, or you can just watch. You're going to have your whole back page is this caliber. So everything we learned so far is more at the regular, secondary 3 regular level. Now let's get to the honors level. It's not any harder. It's just solving it is not going to be always linear and easy. Does that make sense? It's a little harder. Okay, so factor your denominators. Here we go. Let's rewrite these in factored form. So we have 7x plus 3. What is this factor to be? It multiplies to be 15 and adds up to be -8. You're right, x minus 5 and x minus 3, we could quick factor because our leading coefficient was 1. So plus 3x over x minus 5. And then right here, we know it's not in standard form, -x plus 3 will then factor to be Johnny Cakes, are you paying attention? Okay. What? No. I didn't call him Johnny Cakes. 1 over -1. Would I want this -1 in the bottom? Probably not, because I'm going to have to do all this nastiness. 1 divided by -1 is -1 on top. What's my least common denominator? X minus 5, x plus 5, right? So it's really not any harder, as you can see so far. So we multiply by x minus 3, x minus 3, x minus 5, x minus 5. Am I right? Okay, now look, this is the same as this as this. So now we can solve these in the top. So 7x plus 3. 3x times x. 3x times -3. That equals negative 1 times x, negative 1 times 5. Now look, though, this is where people get stuck. You'd say, what kind of equation am I solving here? Isn't it a quadratic? How do we solve quadratics? We get them set equal to 0. Then we solve by factoring, quadratic formula, or most appropriate method. So let's get this one set equal to 0. So I'm going to add x minus 5. Add x minus 5. Now on this side of the equation, let's combine all like terms, putting it in standard form. 3x squared, 7x plus x, isn't that 8x? Minus 9x, and then plus 3 minus 5. And that equals 0. Now you'd solve by factoring. All of yours, I'm going to be straight up honest with you, will factor. Let's factor this. But here's the problem, Mr. Tanner. Does this factor by quick factoring? Good job. So we would drop and break, and you guys know how to do that. So I'm going to just go like a maniac because you already know how to do it. Agreed? Agreed. So then we have that equals 0. So what are my solutions? X equals 1, x equals negative 2/3. Then we've got to check them. And guess what? That's the most missed problem on the test is checking them correctly. So I'm going to scroll back up and check them. Okay, cool. But let's see if we can get this done to checking done before lunch. So somebody pick one, check one, and somebody pick the other. But don't everybody choose one. If you choose one, we know what kind of student you are, the easy getter. You're that student if you pick one out of the options. Just kidding. I'm trying to guilt you into picking the hard one. So we would do 7 negative 2/3 plus 3. Guys, really, the hardest part in getting this right on the test, so don't just say, man, it'll be fine, I'll get it right. Because you won't. You'll get your B, and then you'll complain, and then you know how it is. What I'm saying is, if you're truly wanting to get a good grade, you will practice checkings to say, oh, you know what, though, Miss Christensen, when I check it, I'm not getting it right. Can you help me? Is negative 2/3 extraneous or not? Well, look at that. All of you picked the hard one. You got, it is extraneous or it is not. You tell me. Are you even typing it in? Nope, look at you.
Sorry, more.
Wow. Thank you. Appreciate it. Okay, is negative 2/3 a solution or not? In my box of solutions, should I add it? And is 1 a solution? If not, yes. Okay, flip over to the front. Let me show you something cool. You can solve all the linear ones by graphing. So look, linear, right? We could solve by hand, yes, if we really want, or you could solve by graphing. Now think about it. We want to know when does this function equal this function. Well, if we have a line and we have another line, where they're equal will be where they intersect, right? We could just use our calculator. So go to your calculator, go to y equals, type in y1. I put x over 4, but you could, I mean, it doesn't matter if you put it in y1 or y2. And y2, I put x minus 1, but notice you do have to use parentheses stating what's on top. So x minus 1 is in parentheses divided by 6. Then I hit graph, and look, I can see where they intersect. Somewhere right there. My window's not the best, but I can see where they intersect. Now you'll do second trace. Second trace, we want to know when they intersect. Hit enter. First curve, hit enter. Second curve, hit enter. Do we want it to guess? Hit enter. Well, look at that. It intersects at x equals negative 2. There's my solution. So you could solve if it's linear by graphing. However, there are times when you try to solve by graphing and it's harder to see where it intersects, so you would just go to hand. Do it by hand. I almost think doing it by hand is easier. Everybody see how you can use that as a tool? Okay, so what you can do if you want is 13 through 21, you can solve by graphing. But if you ever graph it and you can't see where they intersect and it's making it harder, just solve by hand. The graphing by solving by calculator is supposed to make it easier, not harder. So maybe practice a few by graphing in that section right now. Okay, let's go to the story problems are the easiest ones. So let's go do some, because I don't want to hear, oh, it's a story problem, so I just skipped it, because these are like the easiest ones. Okay, this is what I've seen on an ACT, so I added it on. Let's do number 28. You're going to see how easy this one really is if you can set it up right. So let's all go to 28 and focus, not just write down what I do. Try to make sense of it. Okay, so it says, one delivery driver can complete a route in 6 hours. Another driver can complete the same route in 5 hours. So everybody think about it. In the real world, if there's 2 UPS drivers and they give each of them, you have 10 deliveries, you have 10 deliveries, it's the same route. You do it on Tuesdays, you do it on Wednesdays. Well, you're a lot quicker. You get it done in 5 hours and you take 6 hours. So what are you doing? Stopping to get chocolates or what's going on, you know? Or are you more experienced and you're just drive a little slower? So let's take a look here and see what this is asking us. So look at part A. So you're going to do this on your homework. Let N be the total number of deliveries on the route. So we don't know how many deliveries we're doing. So N is the number of deliveries, and that would equal 1 route. So maybe it's 10 deliveries is a route. We don't know. So then it says, write an expression that represents the number of deliveries each driver can make in 1 hour. So think about it. If this driver can get it done in 6 hours, that many deliveries, right? That number of deliveries. And this number of deliveries is the second driver, then think about it. N over 6, they want to know how many they can get done in an hour. So N divided by 6 equals 1 hour. That's how fast this truck driver is delivering. This is how many deliveries is happening in an hour if they do it the 1 route in 6. Does that make sense, everybody? We're getting this number done in 6. That would equal an hour. So for example, let's say there's 20 N. 20 deliveries. They get it done in 6. Do you see how we can then pick it apart and say how many per hour you're getting done? If it takes you 6 hours to do 20, then how many per hour? Do you get what I'm saying now? So N over 6 would be how many deliveries you'll get done per hour. And then driver 2, N divided by 5, will be how many deliveries this truck driver can get done in 1 hour. Based on the fact that they get 5, it takes 5 hours to do the entire number of deliveries. Questions on part A. Let's read part B. Write an expression to represent the number of hours needed to make N deliveries if the drivers work together. So now instead of them separately doing it, now they're doing it together. So N over 6 plus N over 5. Do you see how that would be doing the number of deliveries together? And that equals 1. 1 route. That's how fast they can get done with 1 route. All good? Now in part C, because that's them working together. So now so one day their boss comes to them and says, okay, you usually get done in 5 hours. You usually get done in 6. I need you guys to go quick though, because so you're going to go together and get this done as fast as possible. Part C says, okay, well if they are driving together, then how many hours will it take them to do that same route? So our true statement is this. So we have N over 6 plus N over 5 equals how much we can get done in 1 hour. So now let's go ahead and solve. How many per hour are they getting? How much is it taking them per hour now? So let's go ahead and solve for N. Don't I just need to get a common denominator? Okay, let's do it then. So this would be 5 times 5. This would be 6 times 6. What's my common denominator here? 30 times 30. So now my true statement is 5N, because our denominators are the same. 5N plus 6N equals 30. Solve for N. So we have 11N equals 30. N equals 30 divided by 11 is 2.72, everybody. Now on the ACT, they have the answer 2 hours and 72 minutes. And guess what? Statistically speaking, a lot of students choose that option. But here's what you have to remember. 0.72 means 72% of an hour. 0.72, right? Yeah, so you would take 60, because there's 60 minutes in an hour, and multiply it by 0.72. So together they got this done in 2 hours, and then 72% of an hour is 43 minutes, you said? Yeah. Perfect, and 43 minutes. That's way quicker. So it depends on what you're looking at. Would these drivers want to work together? I don't know. Do they want to get paid for 2 hours and 43 minutes, or do they want their full paycheck? Surprise you what people would choose. I always get surprised when people are trying to get out of their 8 to 5 shift early. I'm like, how do you pay the bills? Okay, here we go. Questions on that? Wasn't that not too bad? Let's do one more. Same idea. Number 29. So it says a fountain has 2 valves. 2 drainage valves. So it's kind of like almost split some way. Here's the drainage, one of the drainage valves, and here's the other. I don't know how to draw a very good picture. It says with the first valve open, so let's say that there's covers on this. So now, right now we have a cover on this, and water is pouring in right here. So it says with the first valve open, the fountain drains completely. It's coming through and draining completely in 4 hours. Now, we don't know how much is draining, correct? So X is draining in 4 hours. And then with the second valve only open, so now we're going to close off this and open up our second valve. So putting a lid on this now and opening up this, it can drain in 5.25 hours. So this one's got to be a little smaller since it's taking longer to drain. So X over 5.25 is how much is draining. It says, how many hours will it take the fountain to drain if we now open up the entire thing here? So think about it. If this is how long it takes, plus this is how long the second valve takes, that's how much it will take together to drain one container. So let's solve for X. It's the same idea that we just did. Get a common denominator. Common denominator, 5.25 times 4, 5.25 times 4. So then my true statement here, since I have a common denominator, is 5.25x plus 4x. That equals, if you multiply that out, you get 21. And now solve for x. So that's 9.25x equals 21. So x is equal to 2.27. That's how long it takes. And it was hours. So 2.27 hours. Once again, that would be how many minutes? 2 hours and 27% of an hour. 16 minutes exactly. We could even get down to seconds. We could know when those last driplets are happening, which we're not going to, but we could. So this is kind of like what an engineer would look at in like a real world setting. They look for more efficient ways. So they might say, well, now if we open up something of this largeness, now we can drain that same amount in 2 hours and 16 minutes instead of taking 4 hours like before when we only had one of the drains open and stuff. So that's kind of like what an engineer would do in the real world. Okay, let's go to these ones. You're going to see these are so easy and so fun. What this is called literal equation. A literal equation is just saying, given a statement here, solve for the variable, any variable I tell you to solve for using algebra. So, and you'll see this on an ACT, that's why I added it on there. So what on an ACT would do is they'd say, given this equation, rewrite this equation in terms of B. That means rewrite it as B equals, or get B alone. So it's just use algebra to get B alone. So do you see this semicolon B? That's telling us just to solve for B. So how do I get B alone? Now you can do this many different ways. Let's do the most appropriate, prettiest, quickest way. How should I get B alone using algebra? Wait, what? Times by B? Yes. Times both sides by B. I like that idea. So I have BH is equal to 2A. What's my next step to get B alone? You're right. Now have I reached my goal? B is equal to 2A over H, and we're done. Yay, so this is really just testing, are your algebra skills good or are they not good? Okay, let's do 23, a little bit more advanced one. Okay, so this one's saying solve for D naught. So this is DI, this is D naught. So I'm going to kind of scribble that out. So I can just look at this freshly. Any suggestions? There's so many ways to tackle this one. But there are right ways and there are long ways. You might do it the long way. There's been times when I've been simplifying and done it the long way, and so I'm like, there's probably an easier way to do it. Hey, how should I get D naught alone? Any first step, any suggestions? You could bring that over, but not my favorite idea so far. Common denominator is not a terrible idea, but I do like just subtracting 1 over di. Okay, so we have 1 over f minus 1 over di, keeping your work nice and pretty as future, is equal to 1 over d naught. Now guess what choice they would have on the ACT? They'd say, oh look, all of those are, we can just flip the fractions, so d naught equals f minus di. This would be an answer on the ACT and it would be wrong. You can't just flip the fraction if it's separated by a subtraction sign. Everybody understand? Okay, so any suggestions of how I should get d naught alone now? Yes. You could multiply by d naught. You could multiply by d naught. That's not wrong. But that's just going to take an extra few steps. I would prefer to just make this one fraction. It's going to be quicker if we do that. So we could, like I said, multiply by d naught, but then watch. Do you want me to show you what would happen if we multiply by d naught? Because if that was your first intention, maybe we should look and see, but why would that not be our? Okay, so look. If I multiply by d naught to both sides, that's not a horrible idea. So then I would have this, d naught times 1 over f minus 1 over di equals 1. Now what would be your next step? Divide by that, right? This isn't, like I said, it's not wrong. It's just, the algebra comes out taking a little bit extra steps here. Okay, now this is not simplified, because we know how to divide fractions, don't we? Can we just flip the second and multiply right now? No, you can't do that if you have two things, right? Remember we just learned that the other day? So we would now need to get a common denominator, and then we could flip it. And then we'd be there. That's one way of doing it. So a quicker way is to just get a common denominator from the get-go. So I'm going to get from right here. So I'm going to go back to this step. We were almost just as close right there. But you're going to see how much this might be a little quicker. I'm going to get a common denominator, so I have one fraction, one fraction. Because if I have one fraction, can't I cross multiply? Okay, so let's get a common denominator. Multiply by di, multiply by f over f. So then now we can combine this side. We have di minus f from that all over di times f. Does everybody see? And that equals 1 over d naught. So the algebra is coming out a little bit prettier here. So now to get d naught alone, now it would be a good idea to multiply both sides by d naught. So I have d naught times di minus f all over dif equals 1. Now how would I get d naught alone the best way? I was using pretty algebra. I just didn't put parentheses around all of it, but it doesn't matter, does it? But I could write it like this, couldn't I? Same thing. What would I do next? Anyone? Multiply by DIF. Multiply by DIF. So then look, DIF cancels out. So we have D naught times DI minus F equals DIF. What would be my last step to get D naught alone? You're right. Divide both sides by DI minus F. So the algebra wasn't quite as straightforward on this one. So D naught equals DIF all over DI minus F. Your algebra would have come out how we would have done it the first way, the same way. We would have our common denominator, flipped the second, we would have got here. Okay, cool. Okay, what I want to show you is this one's not on the worksheet. Go to the bottom of your worksheet and do this one with me. Write it down real quick. There's a reason I'm adding it in, because there's a good chance you'll see one similar to the test, and there's not one like this on the homework. So add this one in. We have 1 over c minus c over a squared minus b squared equals 0. Now you might tackle it different than your neighbor. Once again, there's quicker ways and longer ways, but if your algebra is correct, you're going to end up with the same simplified answer. So any suggestions to solve for c? Notice there's 2 c's. Kind of interesting. Any ideas to solve for c first? You could get a common denominator, but then we could get a common denominator. Yes, that's one way of doing it. Not that that's wrong, but I see an easier way. Anyone else have an easier way? No one? I'm going to add this over. So I have 1 over c equals c over a squared minus b squared. Now, yes, we're cross-multiplying, or exactly what you said, we would get a common denominator now. That is what cross-multiplication technically is. It's getting a common denominator. So we'd multiply by a squared minus b squared over a squared minus b squared. We'd multiply by c over c, right? And now can't I ignore my denominator, everybody? Or isn't that the same thing as cross-multiplication, like you said? Okay, good. So now look, a squared minus b squared times 1 is simply a squared minus b squared. That equals c squared. We're trying to get c alone. Next step. Yep, square root both sides of the equation. Now I have c is equal to, plus and minus, because root cancels out with power, the square root of a squared minus b squared. Let's see if you're going to answer my question correctly or incorrectly. Would it be okay to actually now, oh look, yeah, I'm seeing square root and a square and a square. Those cancel out with those. No? Are you sure? You're right! You guys passed the test! That would be breaking the forbidden rule. You can't just square root that, because there's a subtraction sign. Does that make sense, everybody? Very good. This would be our final answer. Okay, cool. Okay, let's see if we have some advanced learners in here. I know we do. So ready, go. Solve for B. I added this one on because it's a little bit more advanced. Solve for B on your paper somewhere. Let's see who can simplify this down completely all the way down. So think about your answer. You'd say, is my final answer considered simplified? If not, take care of that. Answer and see, oh, my answer is that answer. I just didn't simplify all the way. Very good. Very good. You got it. So they got it all the way back there. Very good. So what would your first step be? Multiply by b squared, wouldn't it? That'd be my first step. So then from there, we have, I rewrite it, b squared q over m equals 2v over r squared. What would be my next step to get b alone? Multiply by m. We're trying to get b squared alone, right? So multiply by m. So then I have b squared q equals 2vm over r squared. I'm seeing people do it totally different ways, which is great. Now, what would be my next step? Now, what I want you to get in the habit of, guys, this is going to be really helpful for you. In your brain, dividing by fractions is nice and ugly. Shouldn't I more beautifully think of this as times by 1 over q? Times by 1 over q. Does everybody see how that takes care of q? Much prettier. Okay, so we would have b squared equals, now can I multiply straight across? 2vm divided by r squared q. Next step, square root. So then I have b is equal to, and I know that I need to split this up because I can't have the square root on bottom. So I have the square root of 2vm divided by the square root of r squared q. Now I recognized, oh, this is r squared, square root of r squared, so I can pull out an r. So I have b is equal to, I guess I better add in that plus and minus, the square root of 2vm. All over, I can pull out an r, and I still have square root of q, right? Now what's my last step? Rationalize the denominator. You're awesome. Now, on accident, though, guess what some of you did, and it was so sad because you were so close. You were like, oh, that's gone. But it's not gone, right? Right. B is equal to plus and minus the square root of 2vmq, correct? Square root, we can put them together. And then all over RQ. Awesome. Good job. You guys, you put in valiant effort. I had a few. You get it. Way to go. Okay. Do you guys need more literal equation examples, or do you feel okay about them? You do? Okay. Sweet. I trust your judgment. You're sure? You're sure? Yeah. Okay. Finish the worksheet, though.